Hello everyone, my name is AMMAJI RAO DUPPADA, and in this session today we are going to see an example based on solving higher order differential equation which is linear, nothing but linear higher order differential equation. Why this problem is so important is this is the problem is consisting of all the cases in particular integral, and coming to complementary function. In the solution, the cases are very simple. If you know the roots of the given differential equation or given auxiliary equation, you can write the solution very easily. Now, if you understand this problem, you can understand the whole thing. So the point is here, the given question is looking like this. F of d, it means function of derivatives. Function of derivatives or d terms operating on y is equal to capital X. Capital X is an input. So I told you, in order to find y is the output here, y is the output here, x is input here, f of d is the function of d terms, nothing but derivative terms. Now your solution is small y only in terms of small x, because your input is in terms of small x only. So complete solution is equal to complementary function plus particular integral. So now your x, capital X input having many terms like x1, x2, x3, x4, because there are the four cases in solving particular integral. It means as it is linear differential equation and the system is linear, you can combine all inputs together and you can combine their outputs also. That is what actually linearity we have studied already. So if you understand this problem, it will be very easy solving all other problems. So now what I'm doing is, now first I'm going to solve complementary function in this. To solve CF, nothing but complementary function. What is the basic condition is x or input should be equal to 0 in order to solve complementary function. It means your question becomes d square minus d minus 2 operating on y is equal to 0. Anyhow, y is output, so this is not equal to 0. So what should be equal to 0? D square minus d minus 2 is equal to 0. This is called auxiliary equation. We know that actually. So you solve this one. D square, you can find the roots, minus 2d plus d minus 2 is equal to 0. D if you take common, d minus 2 you will get, plus 1 if you take common, d minus 2 you will get. If you take d minus 2 as a common term of the two terms, you will get a d plus 1 is equal to 0. It means finally you will get two roots. They are d is equal to 2, d is equal to minus 1. D is equal to 2 and d is equal to minus 1. So this is m1, this is m2. Two roots are different, real and different values. So in that case, what is the output? Complementary function is equal to c1 into e to the power m1x, nothing but c1 into e to the power 2x, plus c2 into e to the power m2x, nothing but e to the power minus 1 into x. That's it. This is half of the solution. It means complementary function is over. If you get roots as a repeated, you know how to do. If roots are what do you call complex, you know how to write. If roots are complex repeated, you know how to write. It means half of the problem is over with this. Now coming to particular integral, there are four cases here we need to solve. The four cases are: if you give input as e power 3x, if you give input as sine 2x plus 3, if you give input as cos x into e power minus 3x, if you give input as x square. Now we will see one by one, but finally you can write all together. All functions you can write together. So let me take case 1, e power 3x. So what is the function? Now we are going to solve particular integral, right? To solve particular integral. So I'm simply writing, once again I'm writing this function d square minus d minus 2 operating on y is equal to e to the power 3x. Only e power 3x I'm taking because one by one we will solve. So first 1 over f of d, nothing but what? D square minus d minus 2 operating on x, nothing but e to the power 3x. So this will come under case 1. In case 1, what we need to do? Put d is equal to a, that's it. Put d is equal to a. It means 1 over d square means 9 minus d means 3 minus 2 into e power ax. 1 over 9 minus 3, 6 minus 2, 4. 1 over 4 into e to the power 3x. That's it. It means part of the particular integral solution is over. If input is e power 3x, your output is 1 by 4 into e power 3x. Now, part 2. Your input is, or capital X is, this is part 1, let us say. Now I'm writing here part 2. Part 2 input is what? Your input X is equal to sine 2x plus 3. Sine 2x plus 3. So, how to solve this one? 1 over f of d. F of d means what? D square minus d minus 2 is operating on sine 2x plus 3. So in this case, this is like case 2. What we have to do? In the place of d square, you have to put minus a square. A is what here? 2. It means d square is equal to minus a square minus 2 square, nothing but minus 4. It means 1 over, in the place of d square, if you put minus 4, minus d minus 2 operating on sine 2x plus 3. Still you have to operate because d terms are there. So 1 over minus d minus 4 minus 2 minus 6. You have to operate on sine 2x plus 3. So minus 1 if you take common, 1 over d plus 6. What I do is, what I'm doing here, d square terms are not there. So I am bringing d terms here, d square terms here. D minus 6, d minus 6. Numerator and denominator, I am taking d minus 6. Now sine 2x plus 3. You may think that why we need to bring this d minus x, 6 term extra, because in the denominator you should have d square terms, then only you can put in the place of d square minus a square. Here only d term is there, so for that reason I am taking d minus 6 on both sides. So minus d minus 6 over a plus b into a minus b, a square minus b square. You have to operate on sine 2x plus 3. See, remember this operation you have to do till d terms is missed. You should not have any d terms in the end. So 1 over, okay, minus d minus 6. In the place of d square, you can write minus a square, nothing but minus 4. Minus 4 minus 36. It means minus 40. Sine 2x plus 3. Still d terms are there. Minus minus cancel. 1 over 40. What is the d term is there? D minus 6. You have to operate on sine 2x plus 3. 1 by d means integration, but d means differentiation only. So what you will do here is 1 over 40. Now d means differentiation. You operate on sine 2x plus 3. Sine x, nothing but cos x only. X coefficient is 2, so I am writing 2. Minus 6, you operate on this. Minus 6 into sine 2x plus 3. That's it. Any d terms are remaining in this? No d terms. So we have operated with 1 over f of d on our input. So this is the final solution under part 2. So now part 3. What is part 3? Your input is cos x into e to the power minus 3x. This is like case 4, I think. So in that case, what we need to do, how to solve this thing? So 1 over f of d, 1 over d square minus d minus 1. Sorry, 1 over d square minus d minus 2. Hope we have taken here also, yeah, minus 2 only. Yes. So now you need to operate this with this 1 over f of d on e power minus 3x into cos x. So if this is the case, what we need to do? In the place of d, you have to put d plus a. It means d minus 3, because e power ax, in the place of a, minus 3 is there. So 1 over, so e power minus 3x you can bring left hand side. It means you no need to operate on this. 1 over d square, it means d minus 3 whole square minus d minus d minus 3 minus 2. You have to operate on cos x. So e power minus 3x is anyhow is left hand side, so you no need to operate on this. 1 over d minus 3 whole square, a minus b whole square, a square minus 2ab plus b square minus d plus 3 minus 2 should operate on cos x. So e power minus 3x 1 over d square minus 6d minus d minus 7d 9 plus 3 12 minus 2 10. It means plus 10 should operate on cos ax plus b, nothing but cos 1x plus 0. So here we got. So e power minus 3x 1 over, in the place of d square minus a square, d square is equal to minus a square. Here cos ax plus b, it means cos 1x plus 0. In the place of a, 1 is there, so d square is equal to minus 1. We have to put minus 1 minus 7d plus 10. You have to operate on cos x. So e to the power minus 3x 1 over minus 7d 10 minus 1 9. We have to operate on cos x. So now 1 over minus 7d plus 9, now you have to operate on cos x. You cannot operate because these square terms are not there. So what you have to do? E to the power minus 3x. What you can do is 9 plus 9 minus 7d, 9 plus 7d you can take on numerator and denominator side. This is already 9 minus 7d. Now you taking 9 plus 7d. You have to operate on cos x. So e to the power minus 3x, 9 plus 7d, a plus b, a minus b, a square minus b square. Have to operate on cos x. So e to the power minus 3x, 9 plus 7d, 81 minus d square. In the place of d square, you can put minus a square, nothing but minus 1. It means 49 into minus 1. It means plus 49. 81 plus 49. You have to operate on cos x. So e to the power minus 3x over this constant. 81 means 90 plus 81, 90, 81 plus 49. You can add it. 130. You can put 130 here. 9 plus 7d. How to operate on cos x. Still d terms are there. So e to the power minus 3x over 130 into 9 operating on cos x. 9 cos x only, because directly you can multiply. Plus 7 into differentiation of cos x. Cos x differentiation is minus sin x. That's it. It means e to the power minus 3x over 130 into 9 cos x minus 7 sin x. No d terms remaining. So this is the final solution of the part 3. So how to solve part 4? So here 1 over f of d square minus d minus 2 operating on x square. So 1 over d square minus d minus 2, we can write like 1 over d plus 1 into d minus 2, right? This is another case. So 1 plus d I am taking numerator side. So 1 over d minus 2 I am keeping like this. This is 1 plus d whole inverse operating on x square. 1 over d minus 2, you keep it like this only. Now 1 plus d inverse, nothing but 1 plus x whole to the power minus 1. So you can write this 1 plus x whole to the power of minus 1 is equal to 1 minus x plus x square minus x cube plus and so on. So 1 minus d plus d square minus d cube plus and so on. This many terms are not required, because if you operate with these terms on x square, automatically you will get 0. So 1 over d minus 2, 1 operating on x square, d operating on x square, 2x, different 2 times if you operate on x square, 2x, 2 only you will get. So 3 terms 0. So you can leave here, because d cube, even though you operate on x square, you will get a 0 term only. So this we got. So with the same type, if you want to find this solution also, 1 over d minus 2, it means 1 over, if you take minus 2 common, 1 plus 1 minus d by 2. 1 minus d by 2 you will get. You have to operate on x square minus 2x plus 2. It means minus 1 by 2 into 1 minus d by 2 whole inverse. Have to operate on x square minus 2x plus 2. It is, you can write like 1 minus x whole to the power of minus 1, 1 plus x square, like that terms will come like. So minus 1 by 2, if you expand this thing, 1 minus x whole power minus 1, 1 plus x square X cube term is not required because that terms you will get 0. X square minus 2x plus 2. You have to operate on this. So minus 1 by 2 into, if you 1 operate on this, x square minus 2x plus 2 plus d by 2 if you operate on this. 1 by 2 into differentiation of x square is 2x, differentiation of minus 2x is minus 2, differentiation of 2 is 0, plus 1 by 4 into d square if you operate on x square, 2 you will get. D square if you operate on minus 2x, you will get 0. It means all other terms you will get 0. So minus 1 by 2 into x square minus 2x plus 2 plus x minus 1 plus 1 by 2. Still you can solve minus 1 by 2 into x square minus x plus 2 minus 1, 1 plus 1 by 2, 3 by 2. That's it. This is the solution. Now we have 4 individual solutions. This is the, let us say, solution 4 because this is the case 4 like in the particular integral. This is the part 3 solution, let us say S3. This is the part 2 solution, nothing but S2 you can write. This is the part 1 solution, S1. And complementary function solution also there, let us say S0. It means your complete solution is equal to S0 plus S1 plus S2 plus S3 plus S4. Because when input is 0, you find complementary function. When inputs are there, you find particular integral. How many inputs are there here? 4 inputs are there. So S1, S2, S3, S4. 4 solutions you got. And when all inputs are 0, you get complementary function. Then here in this problem, you got 5 types of solutions. It means as it is linear, your system is linear, your given differential equation system is linear, you can find the total solution is equal to, so finally you have to write this complete solution is equal to, whatever you got in complementary function, that you have to write complementary function, nothing but S0 plus whatever the solution you got for the case 1, nothing but input 1, S1, S2, S3, S4. All terms you have to combine. That is only the whole solution of the given differential equation. You may think like here, if the input is not given in the 4 forms, we have seen 4 forms like, let us say, e power ax, sin ax plus b, another one is x to the power m, another one is e to the power ax into v. For suppose if the input is not given in this forms, let us say they have given like uh, 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 different case like other than this 4. Okay, in that case you have to convert, let us say, another case, another form. Okay, another form they have given. In that case you have to convert, into this form or this form or this form or this form, and then you can find solution. That is the only method, because you don't have the direct method to write the solution for another forms like. Okay, this is the technique you have to follow. So some formulas you need to by heart to do such problems. Thank you all for watching this video.